In 2018, when Subnautica officially released on Steam, it became a hit. Everyone on the internet was talking about it. I remember watching a streamer play the game. It made me want to try Subnautica myself, and I did. I loved it. I loved the beautiful underwater world with different biomes. Each has unique creatures, vegetation, and terrains. I love exploring around and scavenging materials to craft equipment and build a base. The game's scary in a way that makes me want to play more and uncover the mystery of the planet 4546b. I love the game so much that I remember saying on the internet that I would work for a company that created Subnautica in the near future, and I wanted to make a game just like it. But life didn't go as planned. That motivation was faded away. Until recently, I stumbled upon a game called Oxygen Not Included. It is a colony management game that you collect resources, build structures to maintain the survival of the colonists, and expand your colony. The game has over 290 structures for you to build and maintain. That's a lot, and the game didn't force you to play it in any specific ways. You decide what to do and learn from your failed colony. After playing almost 100 hours on this game, an idea sparked in me. What if I combine Subnautica with Oxygen Not Included? What would it be? How would it be like? And that leads to my first ever devlog. But Subnautica and Oxygen Not Included are very different. How do I make it work? I'm gonna make a game that inherits the scary yet beautiful open world you could freely explore around from Subnautica, and combine that with the joy in scavenging materials and building structures from Oxygen Not Included. Here a list about what I want to make: an open world game with third-person perspective, a galactic solar system with many tiny planets, scavenging resources, and building the most advanced technology structures, mysterious hidden story involving giant scary creatures. Those are my main goals. Of course, there will be more smaller goals and features that I want to implement, but let's stick to main goals for now. In this first devlog, I'll try to implement the physics system and basic character movement on spherical planets. I'm gonna use Unity to make this game. I started a new Unity scene and created a cylinder and small box to represent the astronauts, our main character, and their forward direction. I wrote simple character movement and a driver script for the camera to follow the astronauts. This game is a third-person perspective, but also an open-world video game, so I don't want the camera to be fixed in a place like many top-down games. I want it to rotate around based on the player input. In the scene, I'm dragging the right mouse button to rotate camera around the astronauts. I can rotate left and right, up and down. Also, I can use the scroll or the mouse to zoom in and out. With that done, I took some time to update our astronauts' visual, because looking at a cylinder is boring. I used Blender to model our character. At first, I tried to model a cute human character, but it ended up ugly. After many attempts, I decided to model a fox humanoid character, and it turned out okay. I also made some animations for the fox astronauts. This fox humanoid character is temporary. It may be changed in the future. Next, I want to implement the physics system involving many tiny spherical planets. Let's define our rules of physics. Planets have gravity field that attracts nearby objects and pull them in. Planets rotate around their axis. Planets orbit around the sun. These sound like basic concepts that everyone knows about, but how do you actually achieve this in Unity? We cannot use the built-in gravity of Unity physics because it applies gravity in a fixed direction to all objects, which means if the gravity direction is -1 on the y-axis, You will fall off the planets if you stand on the equator or south pole. Instead, we should apply gravity on objects based on their position relative to the planet position. We have gravity direction equal planet position minus object position, and we apply a force towards that gravity direction. We are standing on the North Pole. Let's try going to the South Pole. Nothing happens. We didn't fall off the planet. It's great. So far, we haven't encountered any real difficulties yet. Now comes the most problematic part of this devlog: rotating planets around their axis. Some people may say, oh, it's easy. It's just a simple rotate function. Yes, that part is easy, but the issue arises when the astronaut stands on the rotating planets. Here, the planet is rotating, so is the astronauts. This shouldn't be happening, since in real-life physics, you don't rotate relative to the Earth. Also, when I increase the rate of rotation of the planets, the astronauts seem to slide on the planet's surface. It took me a lot of time to research and find a way to fix the issues. I did come up with a few solutions, but they weren't optimal and even caused more issues. One of those is astronauts running in circles near the pole. Watching it makes me feel dizzy. After 3 days, I finally gave up on making planets rotating on their axes and started to find another way around. If I couldn't simulate planets rotating on their axis, how about faking it? In our solar system, the Sun is in the center. Our Earth is constantly orbiting around the Sun, also rotating on its own axis. But in our point of view, we are standing still. We are the center. The Sun and all planets are orbiting around us. So how do I do it? To achieve this, I separate each planet into two parts: planet true self and planet representative. Planet true self is the real planet by the astronaut's point of view, and planet representative is what our astronaut sees. In order to better present my idea, I make planet true selves as cubes and planet representatives as spheres. The yellow big cube is the Sun true self, the orange cube and the blue cube are planet true selves. First, I need to make sure all the cubes behave under our rules of physics. Planets rotate around the axis and orbit around the Sun. Next, I calculate planet representatives based on their relativities. Scenario 1. Astronauts is outer space and not on any planets. In this scenario, astronauts sees the galactic solar system as it is. The Sun is the center. All the planets orbit around the Sun, so I make sure planet representatives follow the planet true selves. Scenario 2. Astronaut is on the blue planet, the blue sphere. In this scenario, I make the blue sphere stand still and calculate the yellow and the orange spheres based on their relativity with the blue sphere. To calculate the yellow sphere position and rotation, I first calculated position and rotation of the yellow cube relative to blue cube. I drawed a white line to demonstrate the relativity between yellow cube and blue cube. Then I applied the calculated position and rotation to the yellow sphere relative to blue sphere. The cyan line is the relativity between the yellow sphere and the blue sphere. The same for the orange sphere. I calculated position and rotation of the orange cube relative to blue cube. Then I applied that position and rotation to the orange sphere relative to blue sphere. I also calculated the skybox rotation relative to blue cube. Remember, our astronauts can only see the spheres, not the cubes. Here's the final results. On the left window, you can see the blue sphere is moving. It is orbiting around the Sun. Let's approach blue sphere. As soon as the astronaut arrived on the sphere stopped moving and rotating. Now, in our point of view, we are the center, and the Sun is orbiting around us. Next, we want to leave the blue sphere. When the astronaut left the blue sphere, the sphere snapped back to its real position. And that's how it affects the physics system involving many tiny spherical planets. If you like the game and want it to be published, please support me on Patreon. Consider like and subscribe. See you in the next devlog.